Hey, good evening, everyone. Thanks for joining. So we just briefly wanted to touch base on the stuff we've been working for a couple of years, and I think it's more than 8-9 years. I think since ARM Windows on ARM laptops have showed up. I think it was 2018-19 timeframe when Lenovo started hacking on these platforms, and that's when we wanted to give a developer kind of developer experience on these platforms. So since then, we have changed a lot. I mean, we have enabled lots of support, but still there's a long way to go. One of the things which I think we're going to touch base today is just what happened in the last few years, at least last couple of months and year, which changed the landscape by introduction of Snapdragon X Elite platform, which was pretty powerful machine, and people started using it as a developer. But again, it was something a normal user can use it as well. So it was so appealing that a normal you could use it as a normal regular day-to-day drive machine. So the focus for today is just going through some of the gaps which we realize are there in the complete ecosystem itself. It might be because the evolution happened quickly and things were not ready yet, and most of the laptop-based platforms were Intel-centric. So nothing works out of box. So some of the examples are okay. So probably I can quickly go through the status here of T14S. The presentation is mostly focused on the X Elite T14S laptop. So some of the features which work and some of the features which are ongoing as shown. The audio works, and backlight is still, I think it's work in progress. Bluetooth, camera, CPU freak, they're still work in progress. There is some RTC, I think this is still work in progress. I think there's patches in the list. Some of them got merged, I guess. USB-C DisplayPort. I'm currently running on T14S, so it works. That's good. There are a few more things which we tried. I think, for example, the virtualization. So it does work. It's using a hack with SL bonds. Video acceleration works, but still the end-to-end use cases doesn't work. So this is a summary of the end-to-end use cases which are functional and non-functional, and so boot. I think there's probably we can go deep dive into boot. Maybe Chris can explain a bit more on what exactly was the problem and where we are and who's working on what, and similarly other features. Some of the maintainers, I think, who are responsible for these features can talk about it. So let's touch base on the boot. The boot story is pretty complicated, I think. So probably, Chris, do you want to take over and?
Yeah. So the boot problem is quite interesting because there's no real way to determine what the device is to then define what the device tree is. There's some way that you can do it by using the firmware that's actually written into the laptop, but it's incompatible really. So at the moment we're having to hard code what DTB we load. It just causes so many problems. So at the moment we're trying to support this by fixing systemd boot to actually determine what device tree to load. We're hoping to have something that's ready in the next few months. But it's still out of the box, it doesn't work. So
yeah, I think that gives a poor user level experience.
Yeah.
People who want to use it as a daily drive machine, it's very difficult to get the out of box experience. If they have to install Linux, they have to go to multiple loops to fix some of these issues. So there are a couple of things going around in this space. One of them is UK, I think. That's one of the effort, and there's also some effort by Red Hat. They call Nimble. They use kernel as the bootloader itself, and but still there is still no out of box solution which works. This is an open question, I guess, for everyone. So one of the key things what we want to do, what developer is looking for is they can go and install Linux on it without much, knowledge about, copying this DTB. Another is upgrading the DTB files and installing new kernels. So those kind of features, I think, still are the major gaps. Yeah, please. Yeah.
So another thing is that, for example, if you have multiple SKUs of the same laptop, like we do with the T14S, so one of them has OLED, the other one has the LCD. So the way we handle this right now is having 2 separate DTBs. But then if you add another level, I don't know, I don't have an example right now, that means you would end up with 4 DTBs. So I guess at some point overlays would be the solution here, but.
And there's no way to tell at runtime, is there, which?
And you would have to do that before boot, so.
Yeah.
Again, this is an open discussion, please. If you have any inputs or any comments, please, we can discuss.
And we're still waiting for upstream overlay management.
I think the Dell stuff has GPIOs to select that tells something in the firmware what's what, but that's standardized.
And therein lies the whole problem. The fact that, so we needed some mechanism to select between multiple device trees. We need some way to describe these multiple device trees, be it with DTB, overlays, or whatever. But the thing is that the actual thing that selects either a DTB or a DTB plus some overlay, that is at least vendor specific, if not product specific. So if you encode this at the point that is product specific, meaning the bootloader, the UEFI, then you're good. If you try to encode this after transitioning into the OS loader, say system deboot, that means that you would need to make system deboot product specific. And yeah, we heard example of GPIOs, there is ADCs, there is registers in the SoC.
Hardware IDs.
There is, we used to use resistors that you measured with the ADC, and then depending on what range you select the different nodes. We have Lenovo, for example. We know that they are reading bytes from the EC. There's so many variations of how this can be done, and the only way you can implement that is in some vendor-specific piece of code. And the only such thing we want in the end system is the UEFI implementation. So we need to push it there.
I think one of the idea that Casey had was to have a UEFI variable that specifies the, was it you or somebody else, I don't know.
Yeah, and that's a very sensible thing, yeah, if you want to.
Yeah, as at least an intermediate solution, you would just have an UEFI variable that specifies the path to the device tree you use. This still requires that you have a different device tree for every variant. So, for example, the T14S, there's an OLED and an LCD variant. But how to set this variable is a bit of an open question. The easiest potential thing for like all the products that already shipped is that we just build some little bootable image. The user puts it on a USB or drops it in the ESP or something, and then boots this EFI app, which like prompts them the variable to set, and then we just have documentation explaining how to figure it out, and we just add docs for every laptop. And then we hope that on future generations this is fixed, and yeah.
And that's a very sensible idea, because the mechanism of selecting your device tree, the part that has to go into the system deboot or whatever, that's complete generic. And the part that is vendor specific, we push that onto the user or to some vendor specific application, or some application that can contain that vendor specific logic. So I think that's a sensible solution for now.
Yeah, thank you. Okay, so moving on, there is another issue wherein we have the hardware capability of doing video decoding, but we can't really run the end-to-end use case, so nobody can really use the hardware. Stephen, do you want to? I think you had a good presentation in the morning, but you can probably summarize.
Yeah, sure. There was a presentation about that, but just to summarize, so the kernel side, that is all done. Not done, but it's work in progress, right? There's a driver for that. There's more pending patches for like more feature support and so on. So that's nothing I'm very worried about at all. It's more about really making that workable, usable out of the box for a user to actually do, right? You can do all of that. You can create the correct GSMA pipeline to like do the encoding or decoding or whatever you want, and that is fine. But normally, if you just be a user and click on a video that you have on your file or use it up with the browser, you need to like, the system need to detect what is there, need to detect the capabilities, and then actually build the pipeline in a way that is using all the capabilities that's there. So on X86, that's a lot easier. They have like, okay, I think what's called libAV or so? No, the VA, sorry, thank you. LibVA, so that's actually helping to like identify what is there, having the capabilities, and then go from there. So that's something I think that is missing in the bigger ecosystem. And for example, one of the big problems we see here, so on Chromium, there is support because they have their own video for Linux implementations, they can figure that all out. But on the Firefox side, for example, where Brian tried to use it, it's not working at all, right? So, and then you go to other applications that do like video editing and so on. So that's something that's just not there. So most of these people are here like more low-level kernel developers, but we also need to think about like the higher-level end-use cases, like how we could do that. So if anyone has inputs on that, we are more than happy to hear about that. For the recording.
So there was some work at some point, somebody doing M2M libVA support. I think the Sunshi guys were working on it.
Yeah. So it's also the stateless decoder, and now if you have stateful decoder, that doesn't map from the logic in the driver how to do that. So that's we looked into that before. I didn't mention that in the presentation, sorry. But yeah, as Neil pointed out, that is something that is just not matching up with the logic that is happening in there. So we need some other mechanisms also here.
I mean, so on the camera side, you have libcamera that constructs the pipeline for you and feeds the data into Pipewire, and then Pipewire is the abstraction to the OS, right? So you must only implement Pipewire into the browser instead of having an implementation in Chromium and an implementation in Firefox, and then another implementation in whatever application you want. You just implement Pipewire. So potentially, and I mean, maybe there's a project I'm not aware of, but potentially that was something we could do for stateful M2M encoder-decoders, is write a library that will construct the pipeline and then feed the frames into Pipewire specifically, or extend Pipewire in some way to do that.
I mean, in general, what we want, or what I think about is like, you have all the media frameworks, and then you need something on top of that that does some form of heuristic or so to figure out what is there, what is the best approach to use in that case, and so on. But that is not an easy thing to do. And I mean, you could make it in a session media manager or something like that. But yeah, basically that's an open question from my side. So if anyone is more aware of what's going on there, that would be interesting for us to allow that, to have really cater this use case. As I said, on Chromium that's not a problem, but there are so many other applications. And if you really want to have something that in 1 or 2 years time frame you install an application, install a distro on your ARM64 laptop with Linux, and things are just working, then we need to like figure out these use cases as well. So.
Yeah, I think the worry is that nobody's actively working on these problems, which is why this makes very much everybody diversifying their solutions and not working together. So probably this is something maybe we should discuss, I guess, in a bigger forums, maybe somewhere in Plumbers or somewhere in ELCs to.
Also, maybe reaching out to the media people, like maybe there's a conference where they talk about this generic stuff. And so, because I think what we are missing here is, as I mentioned before, we have a lot of people that understand all the hardware, the low-level bits and so on, but like how these people envision the integration of that is something we lack, right? I mean, we could envision something ourselves, but then going and then try to bring that in without like their support, that's not right.
Yeah, again, the distro part distro is also another story here. Like, the Chromium browser needs to be rebuilt with referral support. Currently, Debian distros doesn't have that by default enabled. So that's something which needs fixing as well. So these are some open points on the video side. Moving on, I think we have display. Abel, do you want to quickly?
So I mean, to keep it short, I think the only thing that is still being discussed is the switching between non-transparent and transparent mode for the link tunable training file repeaters, so LTTPR. All of these laptops come with, so actually most of them come with a parade retimer for DP, which needs setting, like before doing the link training, you need to set it to transparent mode and then switch back to non-transparent mode. And this is something that I'm not sure we need to do, but it's already upstream, so it's being still discussed. The other thing is the HDMI. We don't have, there is a converter from DP to HDMI. On the T14S, we don't have documentation for that, so yeah.
Yeah, again, these gaps are probably because the vendor or the supplier of the laptop is not helping us with some of the data sheets, so yeah.
Yeah, so, okay. Brian asked, what's the difference between transparent and non-transparent mode? So basically, with a link tunable training file repeater, you can change some of the electrical properties, let's call them, in order to have the link training successful in some cases. So for example, if you have multiple dongles or stuff, things like that, or depending on the cable that you use, you might not be able to get the link training successful to the sync. So in order to get that, this LTTPR allows you to change some of the electrical properties, I guess, or the signal stuff, related stuff, yeah. And I guess the end goal would be to have per segment. So if you have 3 chained LTTPRs, it would be nice to train each segment of that from the source to the sync.
So what's the status? Anyone looking at it?
It's I think there is Alexander Svinarskis, I think, that sent a patch to do the per segment link training. Yeah, it's under review. I think it's going to be merged soon.
Yeah, thanks, Abba. Okay, so moving on. I think, sorry.
So just from personal interest, I have this Honor something or other X Elite, and display does not work at all. Could this be the problem? I'm running some
Which laptop?
Honor Magic Book or something.
Oh, okay.
This
Display.
Oh,
the
okay, but then the panel itself does not work at all.
panel.
So I was wondering.
That would be a separate problem.
Depends on what type of panel you have.
So it's an OLED panel.
Yeah, I've got patches for enabling the backlight on OLED panels.
No, the backlight works with some, there is some generic Samsung something or other. But backlight works perfectly.
Yeah.
The screen is just gray and there's some pixels flickering here and there.
So, yeah, we need to figure out something for that stage. Yeah.
I think the panel driver might be missing or some timings. Yeah.
So if you don't initialize it or just leave it as is, does seem to sort of work? The backlight works at least.
The EFIFB and see where it crashes.
And there's no crash. Just the panel goes gray.
Right. Okay. We can start it down.
Well,
But also missing from display is the 4-lane DP support. So
Okay.
we are not capable of running the higher resolutions because we are limited currently to 2-lane DP, and we got a set of patches from Neil, I don't know, 2 years ago now, and they solved the problem at the expense of USB having a non-zero chance of dying when we do it. So that needs a little bit of work.
Yeah, I'll capture that.
And there's also MST,
MST.
which I think there is a patch set from Abhinav from Qualcomm. He's going to respin that. At least that's what I got from him. So yeah.
Okay. Yeah. Let's move on.
MST means multiple displays on the same Type C, basically.
Yeah. Multi-stream display. Multi-stream transport. Yeah. Okay. So the next one is USB. I think Abel, is it you?
Yeah. So. Okay, let's pick some of those because it's a long story. So when if you unplug or plug a external display during suspend, that triggers a splat basically, because the I2C controller that where the parade redriver is basically tied up to it's not yet resumed. So there are two issues. One is the G-Link thing that basically schedules work on a non-freezable work queue, which tries to send something over I2C to the parade retimer, and since the controller is down, the I2C controller is down, that triggers this I2C transaction failure, something like that. Also, it wakes up from suspend if you try to plug and unplug. I think Bjorn said that he has some way of masking that, I think, if I understood that correctly.
For the battery notifications.
Oh, okay, so not
battery
for the,
updates.
okay, yeah.
I don't think it covers this part.
Okay. And then multi-port support for, so there are two PHYs. One is USB 2.0, one is USB 3.0. If you have a fingerprint device on the other end, that's only using the USB 2.0. So we need a way to figure out how to turn off the resources from the USB 3.0 PHY. Otherwise, those would be left enabled. Yeah, and then USB 4 is entirely missing for now. I think somebody's working on that, but yeah. Yeah, I guess that's it.
Okay. Yeah. Thank you, Bill. So let's move on. Next is power. I think Stefan, do you want to touch base on the power?
Yeah, so this is mostly something that Johan worked on, who can't be here today, unfortunately. So we've been like working towards actually reaching the deep suspend state, so that if you close like the lid of your laptop, that you actually go to the low power states, that so that it doesn't consume so much power. One of the gaps that we have is that currently to boot you need to disable this unused clocks and power domains thing. So if like a driver didn't like start using, or like didn't broke yet and didn't start using the clock power domain yet, then the stuff in, or like the subsystems in Linux will basically disable those clocks. And we have to use this argument, because if you have those, some of those drivers built as modules and they're only loaded later in the boot process, then those will be disabled already, and you might have the display or other components already or still running during boot, so you will lose like the display, and the whole machine will just hang because there's like accesses made that aren't being processed anymore. Yeah, so there's basically lots of work everywhere needed, lots of optimizations, because really everything needs to work together to reach those deep suspend states.
Okay, yeah, thanks, Stefan. Any questions? Okay, well, let's move on. Next is thermal. I think it's Stefan again.
Yeah, so there are like several components working together on the like whole thermal design of the laptops. So we have Linux, which is responsible to do like passive cooling, which means basically like throttling the CPU and GPU and so on if it's running too hot. So the CPU does it itself, but for example for the GPU we had to add this throttling, so like the maximum temperature at which like Linux will start throttling the GPU. Then there's the embedded controller, or the EC, which is doing the active cooling, so the whole fan control. This is unfortunately kind of something where the like laptop vendors like to do that themselves. So we have, for example, on this Qualcomm reference design, there's one EC that Qualcomm picked, and on the T14S, for example, there's a completely different EC with a different interface that Lenovo picked, and so on for all the like Dell and all the other vendors. And then there's also like the whole battery charging stuff, which is managed by the ADSP on these laptops, which also produces heat and needs to be controlled and so on and so on. So the challenge is basically first that we have like this different thermal design, different EC on all the laptops. And all of these components really need to work together so that we can really like, I mean, you want to have maximum performance basically, but you don't want to like burn your skin because the laptop runs too hot. Then there have also been reports that like laptops shut down because they're going too hot, and then there's some like hardware protection going in. So you don't obviously want to finish compiling your kernel or whatever you're doing and don't want it to like crash immediately in there. If those components don't work together, then you have the risk that, for example, Linux starts throttling the CPU while the EC hasn't even a speed up the fan to run at the maximum speed. So the components basically start working against each other. Linux throttles more and more, and EC thinks, oh, it's getting cooler, so now I can spin down the fan and so on. And regarding to this charging stuff, there's, for example, the issue on the T14S that if you run like high workload, like compiling a kernel and so on, then the whole like charging battery stuff starts to also get hot, and then it basically stops charging, and the laptop discharges during those high loads, even if you have to connect it to a power supply.
Is that still a problem with the T14S? Because I thought that's okay, because I think that's only X13S. Okay.
No, yeah, it's also a problem on the T14S. So what we've been doing, as I said, we have added like for the CPU, GPU, and so on. There's now like thermal management in place so that at least it doesn't get as hot that those would trigger a shutdown. We've also been doing like work on this, skin temperature monitoring, which is basically supposed to prevent that if you touch like the case of your laptop that you would burn your hands because it gets too hot, because right now those laptops get really hot. We have that working on the Qualcomm reference design and partially on the T14S, but it's also kind of tricky to apply to all the laptops because it's also like device specific, and we don't have, for example, schematics or like the exact position of the thermal sensors on all the laptops. And yeah, then for the EC, that basically needs fine tuning. We would need like drivers for all the ECs. So there's some work being done on the Qualcomm reference EC, but for example, there's no work currently being done for the T14S EC. And then, yeah, you can basically like drive this whole thermal stuff to the extreme. So there's also like Daniel now has been doing work to really like fine tune this whole thermal stuff by doing more of the thermal like management and control in user space. We right now have been mostly focusing on the kernel side to really just have those basic safety measures in place. So, yeah.
So touching up on that, so we had a talk with Daniel and Soron 1 or 2 days ago, how we can pick that up from there, because he's not really having time to look into that, like really enables that on T14S, for example, right? So we're looking if we can bring some of the work back into the landing team and have Eugene, for example, looking into that, how we can make that work with the components we're having, so the basic enablement we have been doing compute and so on, but that still leaves the EC out of sight. And then, so EC interaction and ADSP for charging and so on, that's completely missing right now. But that is something at least we want to put on the agenda. No time promises, but at least that's something we can look into. Obviously not for EC stuff like for Lenovo or Dell or something, that's up to them.
Yeah, but I think, even my T14S, if I compile kernel, it's just pretty hot if it's on the lab. So there is a problem there that needs to be fixed. Okay, let's move on. I think we are running out of time. We got a few more stuff. So camera, I think Brian, do you want to quickly go through?
Everything works, it's brilliant.
Yeah, we just hacked. Interestingly, we hacked the camera in a lobby, and it works on T14S now.
Are you going to show the image?
No, I need to flip the camera.
Okay. I'll briefly go through it. Actually, I'm giving a talk tomorrow on aspects of this. So from a high level, the camera that ships with Qualcomm laptops is unsurprisingly derived from the mobile chipset. which means these are MIPI cameras, and they, unlike the UVC cameras that you might use on your USB link, which just outputs, perfect image and you can just consume. The assumption is that your SOC will do all sorts of processing, which of course we are not really allowed to even try to do upstream, but we can get raw data out of there. And last year, Linaro and Red Hat and some interested parties, well, actually over the past kind of 2.5 years really, we've been working with the libcamera people to get debayering, 3A and stuff like that working inside of libcamera. So effectively implementing the algorithms we require to output an image in user space. I've done some work to extend that into the GPU. I'll be giving an in-depth talk about that tomorrow. And on the laptops right now, I can confirm we have the Dell XPS, the Inspiron 14, the T14S as of today, but the image is upside down. And I suspect the Slim 7X will also be working. So that's kind of another problem on top is laptop vendors obviously want to differentiate their camera offering, and you end up with different sensors on the end, which means you need a sensor driver and you need to figure out the sensor driver. I suppose one of the easier things about it is that so far Qualcomm effectively only supports what they give on the CRD. So you might have 8 different CSI PHYs, but every laptop I've seen, it's following the CRD. They put their sensors on the same CSI PHY setup. That's one kind of bright spot, but there's nothing to say, there's nothing to force them doing that. I think it's just easier that way. For example, the Dell laptops don't follow the Qualcomm way of powering up the sensors, but the Lenovo laptops do. And I suspect because the Dell laptops come from X86, they have something working with X86, and they put a Qualcomm SoC down and then just adapted their software stack. So yeah, the kind of cool thing is you can actually run the camera in a Hangouts call. The not so cool thing is the resolution isn't great, and because we haven't upstreamed any of the GPU ISP processing, it is computationally costly. But we're kind of fixing that in the GPU gradually, and I think realistically we will get some sort of generic open source stack that works across different ARM SOCs, X86, and so on. And that will be probably our endpoint for the next couple of years.
Yeah, Brian, I think we are running out of time. We got 4 more slides. Yeah, thanks, Brian. The next one is audio. Audio is functional on these platforms, but the only thing missing on the audio side is some of the protection. For example, the speaker protection itself is missing, which is currently being worked on, and there are some high-end use cases, or there are some modules which can provide you good effects of audio. Those are the stuff which is missing. End-to-end compressed offload. For example, you play an MP3 playback on YouTube or somewhere on the browser. We don't have a clear path to use the offload capability of the Hexagon DSP. That's something missing. I think there was some work there, but yeah, we still need to integrate it. There's another USB offload audio. That support is missing, so that's work in progress. It will be probably, hopefully, in the next couple of months, we should have some of these features. The next big feature is AI and NPU support. Currently, we don't have any AI or NPU support on these laptops. It doesn't work at all, to be honest. So currently, there's an investigation going on how to enable this feature. Next thing is, how do we provide a generic interface to the AI or the NPU subsystem? That's something which is an open item. Again, probably OpenCL or something on those lines might provide some window there, but no one is actually working on it. The next problem we see is the security. I think currently there is no secure QTE kind of support in these platforms yet. There are ongoing work on the mailing list. There's a QTE support patches there. We never tested it on this platform, but that's something probably we should try at some point. And we don't even have integration of TPM or onboard discrete TPM support. That means we can't really run secure use cases. For example, you want to run DRM content, things like that. That's something which is missing. Yeah, and there are some ongoing discussions on secure DMA BoF. As I discussed, the discrete TPM is something open. Someone needs to look at it. There's a last slide. I think gaming. Ettore, do you want to?
Yeah. So these laptops are ARM64 laptops. So we don't have many games that support this by default. So and the other thing is that we don't have really a super powerful GPU on these devices, and external GPUs are not working yet because of USB 4 not available, and many of the laptops out there that don't have like OcuLink or something like that. So basically, it's not an appealable platform for gaming yet, but there is many projects like FXEMU or Box64 86 that are really promising, and seems like many contributors are trying to work on this. And on the driver side, the Mesa project is doing an amazing work on supporting FreeDreno for the OpenGL side and Turnip for the Vulkan side. So it can also be used for like OpenCL applications for the Vulkan side. So it's pretty solid right now, but we need more contribution for making it a stable platform for gaming as well. But
yeah, thank you. Okay, so I think we talked about many problems for the in general on the ARM64 compute platforms. If anyone have any questions, or if you have any suggestions, or some ongoing work, maybe.
I think more than one of these laptops has UFS.
The Samsung one, yeah.
Samsung one, yes.
The Honor also has UFS. There's a PHY missing there.
I think Samsung is upstream, right?
So at least as far as I can tell, the PHY for UFS is not. So the UFS itself is whatever it is, but the PHY for the UFS doesn't seem to be.
So try using, I mean, that's what people did with the rest of the laptops, copying from the existing ones. Try using the same PHY.
Yeah, I did. So there's somebody that got the NetBSD to somehow work with basically not initializing the PHY because it's already initialized. But I guess there's no such work yet in the.
I don't think we have that device though.
No, we don't.
Yeah.
Right. Okay.
But yeah, join the ARM64 Laptops IRC channel. People there might be able to help you with this. I don't know.
Yeah, I imagine that the work is just not done yet somehow, but.
So we don't have all the devices. That's one of the issues.
Yeah, I can imagine that. Yeah, that's it.
Any more questions? Okay, I think we're good. Thank you all. Cheers.
Thanks, guys.